Okay, so in this video, we'll be learning about the magnetic force on a current carrying wire and its applications. So let's say I have a wire of length L and a cross sectional area A and the number density, and the number density is basically the number of electrons per unit volume. So the direction of the current is from left to right. Let's say this end is A and this end is B. So if this wire is placed in a magnetic field, let's say the magnetic field exists in this area and that is going into the plane, that is cross going into the plane, so each of the electrons which are moving inside the conductor will experience some kind of magnetic force. So if I have to evaluate the net magnetic force because of this magnetic field on this wire, I'll just sum all the forces on each of the electrons, the all electrons. Okay, so this force will be the F net on the wire. So let's say we calculate the force on one electron, that is basically getting from this formula Q V cross B. So this is basically minus E, the electronic charge, and the Vd, that is the drift velocity of the electron, and the magnetic field that is going inside. So if I have this is Vd and this cross is the magnetic field going by this V cross B. V cross B will be downwards direction, but since we have this negative sign, so the force direction on an electron will be upwards because there is this negative sign, the negative of V cross B. V cross B, this is basically the cross product. Okay, so this is the force on one electron. So if I have to calculate the net force, then I have to use this F, force on one electron, into the total number of electrons in this length. So if I have the number density n, then the total number of electrons will be number density into the volume of this conductor, that is basically the cross sectional area A into L, that is NaL. So I have the net force is minus E NaL Vd cross B. So if I define a vector, let's say L vector, that is in the direction of current I vector, then as we can see there is this ENALVD, and we also know from the definition of current electricity this I can be written as NEAVD. So NEAVD, this basically goes to I, and I have this vector L that is in the direction of I. So this whole thing becomes basically I L cross B. Remember that this minus vd is the direction of the current, so that is basically giving me this L vector that is in the direction of this current vector, because minus drift, the drift of electrons, it's is happening in opposite direction of the current. Okay, now let's say I have to calculate the net force on an arbitrarily shaped wire. So I have this wire AB carrying a current I, and this is placed in a magnetic field B that is going into the plane. So if I have to calculate the net force on this wire AB, then all I have to do is to calculate the differential forces on each length, because here the direction of force is changing at each point. So I can calculate the differential force on each dl length, and I'll just sum all the values, differential force values, to get the net force. So what is my differential force? Let's say I'm talking about the differential force df, that is basically I dl cross b, where dl is the differential length, this differential length, and b is the magnetic field. So if I have to get the net force, F net will be, this will be basically the summation, the integral of this df all over from a to b, and this gives me I dl cross b, and from this point a to b. Now if I have to do the integral of dl cross b, as I see this b vector is a constant in magnitude and in direction as well, so keeping it outside the integral, I'll get F net will be I this integral of dl a to b cross b. So this a point to b point, I have to integrate this differential length as. So this dl integral will give me this vector ab vector that is going from a to b. Let's say that ab vector length is l. So if this dl vector integration is l, then I can write f net as I l cross b, where l is the vector length ab. Okay, so if I have to calculate the net force on any curve shape wire, all I have to do is to just join the endpoints and draw a vector from one point to another point. Then I'll get some length, and I'll just calculate the net force on that length, and that will be equivalent to our net force on that arbitrarily shaped wire. So let's do some problem based on the net magnetic force on a straight current carrying wire and curve shaped wire. So in this first question, I have to calculate the net force on this loop ACB, and cross magnetic field exists everywhere. So if I have to calculate the net force on first case, F net will be the F on the wire ACB plus F on the wire AB. Okay, so just think about this ACB, it's loop completion is there. So we just knew this TF was I dl cross b, and I was doing the integral of dl. So if I am doing the integral of a to b then b to a, then this integral dl goes to 0. This integral dl goes to 0 because this ACB is a vector in this direction, and I have this BA vector that is in opposite direction. Summation of the vector will be 0. So in this case, this dl is integral of dl is 0. So the net force on this loop will be 0. Net force will be 0. You can also see as if this ACB is replaced by this wire A B, the current going in the forward direction A to B, and then there is this wire B to A, and the forces will be in the opposite direction because the direction of I is different in both wires. So F net will be 0 in this case. So now let's say if I have to calculate the F net in this second case, F net again will be F on ACB plus F on AB. Now replacing this ACB, I just told you earlier that we can replace any curve shape wire with a wire that is coming from one end to another end. Just replacing this ACB with the another wire. Let's say this is A dash B dash. So this ACB F net will be equal to F A dash B dash plus F AB. Now both have the same length, and F due to AB is basically I LB sine theta is because the sine theta sine 90 that is equal to 1, and this F A dash B dash is again I L B, but here it's if I'm saying this curve radius is R, then the length becomes 2R. So F net magnitude will be 2ILB, and putting L is equal to 2R because this length is 2 times of R. This is becomes 4IRB.